There is one photograph in the entire history of the human race that almost didn't exist. Not because nobody wanted to take it, because for 8 straight years, the people who could have taken it kept saying no. 6 separate times, a request landed on a desk at NASA asking for permission to turn a spacecraft around, point its camera back across billions of miles of empty space, and photograph something so small, so faint, so scientifically pointless that most of the engineers in the room could not understand why anyone was still asking. And 6 separate times, the answer came back the same. Not worth the risk, not worth the time, not worth the power. And then, on a single day in February of 1990, somebody finally said yes. What came back 34 minutes before the camera closed its eye forever was not data. It was not a chart. It was not a number on a screen. It was a photograph of everyone who has ever lived, standing on a single point of light so small it did not even fill 1 pixel of the frame. This is the story of the last thing Voyager 1 ever saw, and why the people who fought for 8 years to make it happen were right, and everyone who said no for 8 years was wrong. Let's go back to where this actually starts. September 5th, 1977. Voyager 1 leaves Earth on a rocket, carrying a mission that on paper is almost boring in its simplicity. Fly past Jupiter, fly past Saturn, take pictures, collect data, that's it. Nobody at NASA in 1977 is planning for this spacecraft to still be operating half a century later. Nobody is planning for it to leave the solar system. The mission is built to last a handful of years, and everyone involved expects it to quietly finish its job and go silent sometime in the early 1980s. Except it doesn't. Voyager 1 reaches Jupiter in 1979 and sends back the first close, detailed images of that planet that human eyes have ever seen. It reaches Saturn in November of 1980, and by the time it's done there, its primary mission is officially declared complete. And this is the moment where most machines like this one would go dark. The job was Jupiter and Saturn. The job is finished, but Voyager 1 keeps moving, keeps transmitting, keeps accelerating outward using the gravity of every planet it passes like a slingshot, adding speed, adding distance, heading somewhere no spacecraft built by human hands has ever gone. Now, here's where the story most people never hear actually begins. Because after Saturn, the cameras on Voyager 1 don't do much. There's nothing left in front of it worth photographing. The spacecraft is racing outward through empty space, headed for the edge of everything we know, and pointing a camera forward captures nothing but blackness. But there was a man on the Voyager imaging team who had a different idea. His name was Carl Sagan, and what he wanted to do wasn't point the camera forward. He wanted to point it backward, back at the solar system, back at Earth. Sagan first proposed this idea in 1981. Turn the spacecraft around, take 1 photograph of home from farther away than any photograph of home had ever been taken before. And the response he got was no. Not because it was a bad idea philosophically, because it was a genuinely risky one technically. Pointing Voyager 1's cameras back toward the inner solar system meant pointing them dangerously close to the sun. And a camera pointed too close to a star that bright risked permanent damage, potentially destroying the instrument outright. On top of that risk, there was a cost in something almost as precious as the camera itself. The operations time and engineering attention of a mission that already had a packed schedule and limited resources, all being spent on a picture that, in the coldest scientific terms, would return 0 usable data. Earth, from that distance, would be less than a single pixel. There would be nothing to measure in it, no science to extract, just a point of light. So the mission turned Sagan down, and then turned him down again. This happened 6 times across 8 years, 6 formal requests, 6 rejections, each one weighed against real engineering risk and real operational cost, for an image that had no scientific value on paper whatsoever. If you were running the numbers as an engineer in the 1980s, saying no was the responsible decision every single time. But by 1989, the calculation changes. Voyager 1 and its twin Voyager 2 have finished their planetary work. Voyager 2 completes its flyby of Neptune in the summer of 1989, and with that, the grand tour of the outer planets that both spacecraft were built for is officially over. There is nothing left ahead of either spacecraft close enough or interesting enough to justify keeping their cameras powered on. And here's the part that changes everything, because the cameras are about to be shut down permanently anyway, to save the electrical power that the spacecraft's remaining instruments will need for the long, dark journey into interstellar space. The equation Sagan had been fighting for 8 years suddenly flips. The risk of damaging the camera by pointing it near the sun stops mattering, because the camera's working life is about to end regardless. There is nothing left to protect. And so, finally, on the 7th attempt, the answer changes. Yes. The command sequence was built by imaging scientists Candy Hansen and Carolyn Porco at NASA's Jet Propulsion Laboratory. And it was designed to do something no spacecraft mission had ever attempted before. Not just photograph one planet, but turn around and capture the entire solar system in a single sequence. An actual family portrait taken from outside the family. On February 14th, 1990, Valentine's Day, the sequence executed. Voyager 1, sitting somewhere beyond the orbit of Neptune at a distance of roughly 3.7 billion miles from Earth, turned its narrow-angle camera back toward the Sun and began taking pictures. 60 individual frames, captured across that day, aimed at 6 of the solar system's planets in turn: Neptune, Uranus, Saturn, Jupiter, Venus, and, near the very end of the sequence, at 4 hours and 48 minutes past midnight Greenwich time, Earth. 3 of those 60 frames were aimed at our planet, each one shot through a different color filter: blue, green, and violet, with exposure times measured in a fraction of a second. When those 3 frames were combined back on Earth, they produced a single composite image. In that image, Earth appears as a single point of light, sitting inside a broad, pale band of scattered sunbeam, an optical artifact caused by sunlight bouncing around inside the camera's own optics, because the sun itself was only a few degrees away in the frame. Of the roughly 640,000 individual pixels that make up that photograph, Earth occupies a little over a tenth of one of them. Not a full pixel, not even close. A fraction of a single point of light, hanging in a sunbeam, 4 billion miles from where it was taken. And then, 34 minutes after that photograph of Earth was captured, at 22 minutes past 5 in the morning, Greenwich time, on that same day, Voyager 1's cameras were switched off. Not damaged, not malfunctioning, deliberately, permanently powered down by Mission Command so that the electrical current that had run them for 13 years could be redirected to instruments the spacecraft would need for everything still ahead of it. As of the writing of this script, Voyager 1 has been operating for close to 50 years. It has not taken a single photograph in over 3.5 decades. The very last thing its cameras ever pointed at, in the final minutes before they closed forever, was the sun itself. And the second to last thing they saw, 34 minutes earlier, was us. Here is something that almost never gets said clearly enough. It took months for that photograph to even reach human eyes. The image data was stored on Voyager 1's onboard tape recorder after it was captured. And because NASA's Deep Space Network, the system of giant radio dishes that communicates with every deep space mission, was giving priority scheduling to other active missions at the time, the full transmission wasn't completed until May 1st, 1990, nearly 3 months after the shutter closed. And when the data finally did arrive and someone sat down to actually look at it, the experience was not what you'd expect. Candy Hansen, the imaging scientist who was the first person to see the photograph after it came down, later admitted that finding Earth in the frame was harder than she expected. It didn't announce itself. Because of that stray beam of scattered light running diagonally through the image, the small blue point representing our entire planet didn't immediately jump out. She had to look for it. And once she found it, once the image was processed and released to the world, it became something that a single photograph almost never becomes. Carl Sagan, the same man who had spent 8 years fighting for this exact picture, wrote about it in a 1994 book that took its title directly from what he saw in that frame: Pale Blue Dot. In it, he described looking at that single point of light and understanding, in a way that no telescope or equation had ever made him understand before, that every human being who had ever lived, every war, every triumph, every person you have ever loved, had lived their entire existence on that one dot suspended in a beam of light. He called it a demonstration of the folly of human self-importance, and argued that seeing our world from that distance carried a kind of responsibility with it, a responsibility to treat each other and the only home we have with more care. What makes this photograph different from almost every other famous image in the history of space exploration is that it was never supposed to exist. It has no scientific value in the way that data from Voyager's other instruments does. There is no measurement to take from a fraction of a pixel. It exists purely because one scientist refused to stop asking, and because a closing window of opportunity finally aligned with an engineering situation where saying yes cost nothing anymore. If Sagan had gotten his answer the first time he asked in 1981, the picture might have been taken with the cameras still needed for years of active use ahead, and the risk calculation would have been genuinely different. If the shutdown of the cameras hadn't happened to fall in February of 1990, the picture might never have been scheduled at all. This photograph exists in a narrow, specific window of circumstance that almost didn't open. And it is worth being honest about something else too. The pale blue dot did not become one of the most famous photographs ever taken purely because of what is visible inside it. On its own, without context, it is an extremely faint dot inside a smear of lens artifact, the kind of frame an engineer might otherwise dismiss as barely usable. What turned it into something the entire world recognizes decades later was the writing Sagan built around it. The photograph supplied the fact that from far enough away, Earth is almost nothing. The words supplied the weight. Together, they became inseparable, and the image outlived every technical justification that had once been used to argue against taking it. Voyager 1 was not finished after that day. Its cameras were gone for good, but its other instruments kept running, kept collecting data about the outer reaches of the solar system. And in August of 2012, more than 2 decades after that final photograph, Voyager 1, Voyager 1 crossed the heliopause and became the first human-made object to leave the solar system entirely, continuing to transmit data from interstellar space, a region no instrument had ever measured from the inside before. But it did all of that blind. Every discovery Voyager 1 has made since Valentine's Day 1990, every boundary it has crossed, every reading it has sent home from the edge of interstellar space, has come from a spacecraft that can no longer see anything at all. It travels through regions of the galaxy that no human eye and no human camera will ever witness directly again from its position, moving further from home every single second, carrying with it the last picture it ever took. A fraction of a pixel of blue light, holding everyone who has ever lived inside a sunbeam 4 billion miles from home. Only 2 other spacecraft in history have even been capable of attempting something like that family portrait from that kind of distance and vantage point. Voyager 1's twin, Voyager 2, and decades later, New Horizons on its own journey past Pluto and beyond. No other mission has repeated it. No other spacecraft has turned around from that far out and photographed the solar system as a whole family of worlds, seen from outside its own front door. The family portrait remains to this day the only photograph of its kind that has ever been taken. And there is no mission currently funded or planned that would produce another one any time in the coming decades. So the next time you see that faint blue speck sitting inside its beam of scattered light, understand what actually had to happen for it to exist. It took a scientist willing to be told no 6 times across 8 years, and ask a 7th time anyway. It took a closing window where risk and permission finally lined up for one single day. It took 34 minutes. Between the last photograph of Earth ever taken from outside the solar system and the moment that camera closed its eye for the final time in human history. And it took almost 3 more months after that, just for the signal carrying that photograph to fully arrive across the growing distance of space, before a single person could look at it and finally see, for the first time, exactly how small and how singular, and how entirely alone in the dark our whole world actually is. If this is the kind of story you want more of, stay close, because there is more to uncover about what this spacecraft has seen, what it is still doing right now, and what is still left to learn from a machine that has been quietly rewriting what we know about our place in the universe for nearly 50 years.